All right, moving on to the next section, it says to make a conjecture about the common difference d from the explicit formula for arithmetic sequences and the a value of the linear function. So let's remind ourselves what the d value even is. The d value is this number over here, which is your common difference. So it's a number that you're adding or subtracting every single time in your arithmetic sequence. And the a value of the linear function is this one. So that would be this number and this number. So you're noticing, hopefully, that in our first problem, the d value was 6 and the a value was 6. In the second problem, you notice that the d value is 10 and the a value is also 10. So what do you guys think? I'll give you guys some time to write down your conjecture, and after you unpause the video, I'll write down my conjecture. Okay, so unpausing, I'm going to write down my conjecture. My conjecture is that the common difference d is the same number as the a value of the linear function. Okay, so my conjecture is that they are the same number. It appears to be true, but we haven't formally proven it yet, but I think they look like they're the same number based on our two examples. All right, let's go on to 3 and 4, which is the same as 1 and 2, except we're just graphing it. So when I say that, I mean like this answer for number 1 is the problem we are graphing for number 3, and this answer for number 2 is the problem we are graphing for number 4. Okay, so we're just going to continue those two problems and we're just going to graph it. So our instructions say graph the function for all integers n such that 1 is less than n, which is less than or equal to 10. So we're just graphing for all the n values. I'm just labeling that just because I want to. Okay, so before we graph it, let's make a t-table. So you can see that we provided a t-table on the side. And for this t-table, we're just going to plug in this number, whatever it is there, into the n value, because this entire column is the n value. So watch how I plug it in for the first one. So 6n plus 6. 6n plus 6. So 6 times 1 plus 6. If you were to type this in the calculator, you would get 12. So my first point is 1, 12, which I have marked on the graph already right here. Let's take a look at the next problem. The next problem says our n value is 2. So what number am I going to plug in? 2. 6 times 2 plus 6. I'm using this equation and replacing the letter n with the number 2. So when you add this together, or multiply it and then add together, you will get 18. So my next point is 2, 18. Put a point over here. The next thing is plugging in the number 3. So let's do that. 6 times 3 plus 6. You plug that in, you're going to get 24. So my next point is 3, 24. And then as you keep going, you're going to go 6 times 4 plus 6. And that will give you 30. So my next point is 4, 30. Then 6 times 5 plus 6 gives me 36. So this point is 5, 36. Oops. Okay, and then 6 times 6, and then adding. and that should give me 42. So 6 comma 42. The next one, plugging in 7, should give you 48. Plugging in 8 gives you 54. And plugging in 9 gives you 60. Gives you 60. And plugging in 10 gives you 66. It's okay, it's off the graph, it's totally fine. Just estimate it's about right there. And you will notice that we have formed a straight line. So connect everything with a straight line. Okay, so here's my straight line. This is my linear function represented by the arithmetic sequence. Okay. So our initial arithmetic sequence for number 1, you can turn it into a linear function and graph it. So that's what we have just done. We're now going to do the same thing for number 4. So number 4 started off with this arithmetic function right over here, and then we turned it into this linear function, and now we are about to graph that exact same linear function by plugging in n values. So first of all, let's plug in n value of 1. So I have 10 times 1 minus 35 gives me negative 25. So my first point is 1 comma negative 25. Then our next point, we are plugging in the number 2. So we have 10 times 2 minus 35. So then this gives us negative 15. So my point there is 2 comma negative 15. Third point, we are plugging in 3. So 10 times 3 minus 35. I get negative 5. Plug in the point over here, 3 comma negative 5. Continue plugging in 4. And we get 5. So 4 comma 5 is this point. Plug in the next point. Get 15. So the next point is 5 comma 15. Plug in the next point. And you get 25. Plug in the next point. You get 35. So that's 7 comma 35 over here. Plugging in the next point. You get 45. That's over here. And it's okay if our graph continues on top. It's totally fine. We have 10 times 9 minus 35. You get 55. I'm just going to say it's about there. And the last one, 10 times 10 minus 35, and you get 65, which I'm going to say looks about there. You don't need to be completely accurate. It's just us plotting points outside of the graph, so it's okay. And when you're finally done, connect it all with a straight line. And there we go. So in this example, we learned to graph the function for all integers. So we started off with an arithmetic sequence, we turned it into a function, and then we graphed the function.